Now, if you're ready to tackle square roots, it must be because you've already mastered the module called square and triangular numbers. Now, square numbers are ones that you can literally make into a square. If I give you 1 counter, 4 counters, 9 counters, 16 counters, you could arrange those into what would look like a little square arrangement. It would be either 1 lot of 1, 2 lots of 2, 3 lots of 3, 4 lots of 4, and so on. So they actually look like little squares when you arrange them. Now, if you understand how to square a number, you'll know that you can write it like this, which is to basically raise it to the power of 2. That's what squaring something means. We put the little 2 up there to show what it is that has basically been multiplied by itself. So, for example, 2 squared means 2 lots of 2. 3 squared means 3 lots of 3. We multiply the number by itself. And it's important that you know that we're multiplying the number by itself, not just multiplying it by 2. So we're familiar with our square numbers. What we need to do with square roots is actually go back the other way. And just like when you learnt to subtract, you found that it was the opposite of addition, and when you learnt to divide, you found that it was the opposite of multiplication. Taking a square root of something is the opposite of squaring it. So if you were to start with one of these square numbers and put it inside one of these brackets, what we're saying is, what number times by itself is 1? And the answer is 1. What number times by itself gives me 4? And the answer is 2 2s are 4. So we can work backwards this way and make a bunch of statements that are basically the opposite of these ones. What number multiplied by itself is 9? And the answer is 3. What number multiplied by itself is 16? So we can go on with these, and as long as we put a perfect square number in there, it's really nice and easy to calculate the answers to these because we know our times tables. Now, if you have a number inside a square root bracket that is not a perfect square, you can still calculate it, but you're going to need your calculator to figure out exactly what it is. This is not something that's easy to do in your head. And so if you're looking on your calculator for how to do this, you hit this square root button, which is right here, and then you can put any number inside. So let's say we were to look at, say, the square root of 20 and hit the equals button and see what it is. 4.472, it goes on and on and on, right? So there's a couple of modules here that you can look at. The first one is just square roots, and it's actually understanding how to look at a question like one of these and how to get the answer. The next module after that is called estimating square roots. And it's really just checking your knowledge, whether you understand the pattern that goes on with all of these. Now let's just take the number that we looked at with our calculator, the square root of 20. In this module, estimating square roots, it asks you to figure out approximately how big this would be. Now it's almost impossible to do it in your head, even with pen and paper. It's very, very hard to multiply something by itself when you don't know what it is that you're multiplying. So square roots are notoriously hard to figure out, but we can use these as our benchmarks. So if we know our times tables and we can see that, all right, I know that the square root of 16 is 4, and I know that the square root of 25 is 5, I can see that this one looks like it would fit in somewhere between these two. Why? Because 20 is in between 16 and 25. It's smaller than 25, but bigger than 16. So it makes sense that the square root of 20 is going to also fit somewhere between these two numbers. It will be somewhere between 4 and 5. Now that's about as close as I can get. I sort of feel like it would be round the middle because 20 seems about halfway between 16 and 25. But they're not easy to estimate except to say it's somewhere between 4 and 5. Let's have a look at another one. If you were to estimate the square root of, let's say, 60. Now the trick to doing this is working out where it would fit, and we haven't extended our pattern down this far. So what you're looking for is two square numbers, one that's smaller and one that's bigger. So if you think through 7 7s are 49, so the square root of 49 is 7, and 8 8s are 64. Can you see how 60, the square root of 60 must be somewhere between the square root of 49 and the square root of 64, which we know is 8. So that tells me that this is going to be 7 point something. I'm not quite sure what, but this module just asks you to estimate which whole numbers this would fall between. And it's going to be between 7 and 8.